So today we're going to be learning how to plot logarithmic regression curves for Bitcoin in Python. So if you haven't seen one of these graphs before, they look a bit like this one. So I'm on moonmath.win here, where you can see a publicly available graph. And this one was plotted in 2014. And as you can see, it captures the price action quite well, considering that no more data was added after 2014. So hopefully with all the data we have now, the model will work even better and we'll be able to get better price predictions from it. If you're into Bitcoin technical analysis at all, you'll know that this is a very common model that people use. Here it is on lookintobitcoin.com. And the one that we're going to create today will look something like this one. So as you can see, we can spot clear resistance points on these bands and gain some sort of insight into how the crypto market works. So for example, we could observe that all of the peaks in the crypto market have been roughly towards the top edge of this golden band here. Whereas the bottoms of the bear markets have been increasing by one band every time. So it was in the violet band, then it was in the red band, and then most recently the bear market ended in the blue band and is going up. That would suggest that the volatility of Bitcoin is decreasing over time. So if we're going to plot this graph, the first thing we need is a good source of data for Bitcoin prices. Now, the best one I've found is this website called Quandl.com. So if you go to this link up here, you can get Bitcoin price data going all the way back to 2010 and 2009 even, when Bitcoin had no value. You do have to sign up for an account, but it's free. They don't ask for your credit card, and you can probably just use a throwaway email if you want. If you don't want to sign up for an account, you can go to cryptodatadownload.com, and these guys just have CSVs that you can download off the website. The main issue is they don't have data that goes back to 2010. This data goes back to about 2013. So if you go on their UK and US exchanges, you go to Kraken, and then you can get the Bitcoin USD daily, hourly, or minutely data. You can also do this for lots of other cryptocurrencies if you want to try and apply this model to those currencies as well. So with that said, let's jump into Python. So if you're just looking for the code, you can pause the video now and copy what I've got on screen. And that'll work as long as you've got the correct modules installed and you've downloaded the price data from Quandl. You've named it prices for, and you change the headings here to the non-capitalized versions. So let's get started on going through this code. The first thing we're going to do is we actually need to load the data, right? So we're going to need to import pandas for that. So import pandas as pd. And then we're going to use the pd.readCSV function. And I've named my CSV prices for. So I'm just going to put prices4.csv. Make sure it's in the same folder as your Python file. Otherwise, pandas will have trouble locating it. The df for data frame is equal to pd.readCSV, and then let's print that out to make sure it's loaded properly. There we go, we've got all our rows and all our price data. So the first thing you might notice is this data is back to front. So normally in a graph of price data, you would have the earliest data first and the most recent data to the right of the screen. You plot this data as it is, you'll get that the opposite way around, so you'll be going backwards in time. Easy fix, all you have to do is say df is equal to df.eloc, and then we give that a slice and just go -1. So step through the data -1 at a time, and so it essentially just reverses a list. We're also going to want to exclude any data where the value is equal to 0, because we're using a logarithmic regression, and if you do the log of 0, bad things are going to happen. So to avoid that situation, I'm just going to exclude all data where the value is equal or less than 0, but it's not going to be less than 0. we also need to make sure the date column here is a Python datetime. So we're going to do pd.toDatetime and then just put in df date. If you don't do that, the graph will probably break quite spectacularly, so I recommend you put that line in there. So this won't have any noticeable impact really, other than the directions now in the correct way. And our first value here is in 2010, not 2009, and the value is non-zero. So we're looking good. We'll label that data pre-processing. Okay. So the next thing we're going to want to do is define our logarithmic regression function that we're going to fit the data against. So let's define a function, and it's going to take an independent variable, which is the amount of days since the start of the data set. Then it's going to take two other variables called p1 and p2. And so we're going to return p1 times np.log of x plus p2. So let's import numpy so that Python doesn't complain. And there we go. The next thing we're going to want to do is actually fit the data. For that, we're going to need to import from scipy.optimize import curve fit. So we'll use that in a second here. We just need to prepare our x and y values that we're going to fit. So our x data is simply going to be a numpy array of the days since the start of the data set, basically. So all that means is just a list from 1 to the size of the data set. X plus 1 for x in range len df. Just using a standard Python list comprehension there. And then our y data is going to be the logarithm of Bitcoin's price at any given time. So np.log df value. And then let's extract our optimal coefficients from this. So we'll say p-opt, which will give us our coefficients. p-cov, the covariance between them, which we won't bother with, is equal to curve underscore fit, our function, our x data, our y data, and then our initial guess for the variables. So 3 and minus 10 should work fine. This initial guess is just in there to help the algorithm optimize. I don't think you have to put it in there. I think it will guess on its own, but just to be safe. And let's print out our optimum values just to make sure that we've got something. There we go, that's about right, 3 and minus 15. So we're looking good so far. Let's label that regression fitting. So we're approaching the end now. Now we just need to actually plot the data. So for that, I'm going to import matplotlib.pyplot as plt. And then all we have to do is do plt.semilog y. So we're going to do a log graph of the values, so df of the dates rather, so df dates versus the value of Bitcoin at the time. So df value, don't forget this is a logarithmic chart, so that's because I've done semi-log y, so the y-axis will be logged and the x-axis won't be. Obviously we have to plt.show, otherwise the graph won't show up. And there we go. Let's change the style of this graph to dark background, just because I like that more. plt.style.use dark background. There we go, looking a bit nicer, but it's still just a graph of Bitcoin price. Let's plot our actual data. So to do that, we're going to need to generate our fitted data according to the model that we've just created. And so to do that, let's just do fitted y data, let's call it. And that's going to be equal to our function, so our model that we've just created, with x data, so just the days since the start of the model. And then we need to put our two values in there. So POPT, if you remember, contains those values. So POPT0 and POPT1. And so let's plot that on the same graph. plt.plot. We're going to, again, just plot the dates on the x-axis. And we've got to remember to exponentiate this. So if you remember, we fitted that data against the log of Bitcoin value. Whereas now we're plotting the actual value here. So we have to exponentiate our fitted y data. You can try not exponentiating it and it will look ridiculous. So you can see why we have to do that. Okay, so this is, it's looking decent. There are a few problems with this graph. So the first thing we're going to fix is that the graph extends here into very small numbers, 10 to the minus 2, 10 to the minus 4, and it just looks ugly. So to fix that, you just do plt.ylim, and then bottom equals 1. And there we go, that's a little bit nicer. Now, the second thing you're going to notice is that this is sort of going directly through the middle of the data, which is, it's helped. You can identify points of resistance like this, for example, and here, again, on the downside. But we want more of these lines, basically. So let's use a for loop and plot a lot of them. So let's do for I in range. We'll do -3 to 5. You can, of course, experiment with this. And then all we'll do is plus I inside this exponentiation here to each one. And so if we run that, we'll generate a whole bunch of lines, and Matplotlib will automatically take care of the coloring for us. So some of you might actually prefer this. That's why I put this in here, as opposed to the bands, which we're going to generate next, as you can see more clearly where the edges of the bands are if you've just got the lines. And so let's now use the plt.fillBetween function. And what that will do is help us generate the bands. So fill between. Make sure we're inside the for loop there. So as usual, you just provide your x data. So for us, that's df date. And then you want to provide the bottom of the curve, which for us is going to be np.exp fitted y data plus I minus 1. So since I is increasing one at a time, if you take 1 from it, you will get the top of the curve below. It'll make more sense when we plot it. And so the top curve, which is going to be the top of each band, is just going to be np.exp fitted y data plus I. As you can see, there's a gap of 1 between them, which is the distance between every band, because these lines were 1 apart inside the exponentiation there. And so if we plot that, we should get a nice colourful array of bands. The colours are a bit insane on this, so if you just use the alpha variable and you set that equal to about 0.4, the graph starts to look a little bit nicer. There we go. So this is the example that I showed you at the beginning. I'm going to be making more tutorials on basically all of the common Bitcoin data science models that people use and how you can make them for yourself in Python. Feel free to have a play around with this. You can decrease the width of the band by changing how much I increases on each loop. You can extend this out to a further range by providing more dates. There are lots of different things you can do with this. So yeah, have fun.